want to start the recording?
Recording in progress.
Okay, so let's begin. So it's a great pleasure to have as our speaker today William Stein, the founder of SageMath and CoCalc. He received his PhD from Berkeley in 2000 and held positions at various institutions and was a professor at UW before founding SageMath. So he'll be telling us today about CoCalc. And I'll just say, so if there are any questions from the audience, you can just leave them in the chat, and I'll monitor that. And William has said I can interrupt him during the talk. And then afterwards, there should be a separate link that Gilad sent out for kind of a different session with William for graduate students. But anyway, without further ado, William, please begin. Thanks.
Thank you. So as the other Will mentioned, my background is pretty academic. I got a PhD in pure mathematics from UC Berkeley in 2000, and then I was an assistant professor at Harvard until 2005, mainly doing research in number theory, and in particular on elliptic curves and modular forms. And in 2004, I started SageMath, the open source math software project. And the goal of that project was to take the ecosystem of all open source math software, or at least the best of it, put it together with Python and do whatever work was necessary to provide something that would be a free and open source alternative to Maple, Mathematica, and Magma. Mainly, initially at least, for research mathematics, but it also got pretty popular for teaching, drawing plots, teaching calculus, that sort of thing. And we ended up having a lot of Sage Days workshops over the years. There's a link here to over 100 of them that we've had. And one of them in 2012 was at IMA. So it's not the first time I've spoken at IMA. I worked a lot on SageMath and also research as an academic until 2019 at University of Washington, where I also taught a lot of undergraduates and grad students along the way and got them involved in writing software and research. And then in 2019, I left University of Washington and started a company. And the main product that the company has created is called CoCalc. And to give you a little bit of background on why it exists and what the motivation is for, over the years, I built a number of clusters and then had mainly research mathematicians and people working on Sage from all over the world would use these clusters, and my students and other people's students, to get work done. And the first cluster I built was at UC Berkeley. We got some grants and put it together a couple of computers. And the cluster is called CrackPipe, which is kind of a funny name. Kevin Buzzard named it that. And then, but it was useful by grad students and researchers. And then at Harvard, we built another cluster, which you can see pictured on the right, called MECA, which stood for Mathematics Extreme Computation Cluster at Harvard. And that was mainly funded by Will Hurst, who is undergraduate at Harvard long ago and liked to donate money to support the department. I remember at the time, he's like, if you had 10 times as much money, what would you build? And CoCalc is kind of the answer to that question. After being at Harvard, I went to UC San Diego, and then went to University of Washington, and I got a pretty generous SCREMS grant from the National Science Foundation. It was over $100,000, and I built a pretty substantial cluster on campus there with a full rack that I had full of computers in the they had like a server room in the math department, and then there was another serious data center across campus where I put some servers. So I got to manage a lot of computers over the years and see what the trade-offs were. I also taught a bunch of classes to students where usually what I tried to teach them was how to use Python and Sage and LaTeX and the Linux terminal and all these other things. And they would do collaborative final projects and coding labs. And I also like to organize peer grading where the students would grade each other's work just to give them more of a feel of kind of how research mathematicians work, where there's peer review, and also to improve the quality of the grading. And I wrote books with people and papers, did all the academic things. And I also wrote the first web-based computational notebook, which it was in 2006, so a very long time ago. And it initially looked very similar to how Jupyter Classic now looks, except it was many years before that. And it was kind of motivated by trying to make something like IPython or Mathematica notebooks, but in a web browser. Mainly because web browsers are a lot more accessible and easier to program, even in 2006, than writing local GUI applications. And also, once you make it available, anyone can use it, which can be really useful. So the goal with CoCalc, which I looked in the Git log, I started in 2012, a long time ago, although there was no release at all that anyone could use until at least a year later, but was to build a single unified piece of software that would cover all of the use cases I mentioned above. And it evolved over the years to cover things that other people demanded and really wanted. The other second goal of starting CoCalc was to build a business that would highly value pure math research software so that it would be something that could fund development on Sage. Sage it's got like a lot of maybe money for workshops. That's why we've had over 100, but it's extremely rare that we've ever had one person that could just focus full time on Sage development for any amount of time. So it's kind of chronically underfunded, unfortunately. So being at the university and then declaring that I'm starting a business introduced some interesting early challenges. So the first thing is that I started writing a lot of code for doing what I listed before in a way that could be shared with other people, and maybe eventually they would pay for it and support it that way. And pretty quickly the university explained to me that if this is a commercial type of thing, then they owned it completely and they might license it so that I would be able to do something with it, but they're going to take a major cut. And I was concerned and confused by this, so I asked around to other professors who had done similar things. It's not that uncommon to try to spin a software company off from the University of Washington, and heard some pretty serious horror stories where they wanted 50% of all revenue forever. And it's really kind of impossible to actually build a software business under conditions like that. Fortunately, I just started searching around in my grants that had funded work on this software, and some, I guess, clever grant program officer had said that if you apply to a certain grant, then you have to say in the grant that all software you write funded by that grant must be open sourced. And I was, I diligently put that statement in my grant proposal, and UW signed off on it, and I received the grant, and it funded a lot of work. And so they actually had to just open source all the software. So that was a nice surprise, so I didn't have to start over. So I worked for quite a long time on CoCalc while also teaching, sometimes a full load of classes. And I'm sure you've all kind of experienced this in various things, but it got kind of extreme where there was a lot of tension between the two activities. I remember once I was about to teach a class to a bunch of undergrads, and suddenly CoCalc got hit by a distributed denial of service attack. And so it's just like the site starting to go down. I was going to use it in the class. We have lots and lots of people using it all over outside of University of Washington as well. And I'd really like to address the problem. and somehow deal with it, but I, dutifully march off and give a lecture and then try to run like an interactive thing with the students, which doesn't work because the site's down, and start seeing all these emails from other users who are complaining. And I really want to address focus on the actual problem. So, little did I know how many other similarly painful situations would arise, over the 10 years after that, even when I could focus full time on it. But anyways, there was a lot of difficulty there. Also, the university, basically, if you worked on something part-time and you were working less than 50%, it was very easy to keep the IP separate from the university as long as you didn't use, their resources. But as soon as you exceed 50%, it becomes a lot harder. And they wouldn't let me stay less than 50% for more than 3 years. So I was kind of, had to choose between developing CoCalc or leaving. And I chose to leave so I could focus full time on that and also have like really clear intellectual property. So those are some just like little early challenges with balancing being an academic with trying to start a company. And they felt like huge challenges at the time, but if you're an academic listening to this right now, thinking of starting a company, I would encourage you to seriously consider it. It's extremely interesting seeing how often things are kind of reversed in the in the business world versus in academia. There's just so many things that are kind of flipped around in terms of priorities, timelines, how decision making is done, and so on. And I guess this very seminar is about kind of that subtle tension, I think. Another thing, so there's two very different pieces of software that I have spent a lot of time working on. One is CoCalc, and the other is SageMath. And they're really diametrically at the end of two very different spectrums in many different ways. CoCalc is a distributed web application, and it involves real-time collaboration, chat rooms, running lots of computers at once, auto-scaling type of stuff, and a lot of other things. And the sort of algorithms that are involved, the software stack that's optimal, the programming techniques, the sort of bureaucracy you have to deal with to make it viable is kind of in a completely different box than Sage. So Sage is it's mainly a piece of software that implements an enormous number of algorithms from pure mathematics, enumerating prime numbers, factoring integers, linear algebra type of stuff. And very often the algorithms, use as much CPU as possible in their one little place, and they're not really about organizing a bunch of resources all over the place. And then also the way development works, it's pretty easy to parallelize Sage development. It's easy to have lots and lots of different people working at the same time without interfering with each other and have it really, in a valuable way, grow to be more and more useful. And also, once you choose, the tech stack that we built and chose for Sage, I chose Python in 2004 because it was very similar to Magma. I looked at a lot of different languages, but it seemed like a good choice, and it was possible to easily extend in C. And obviously, over the years, Python has turned out to be a good choice and extremely popular, and I think a lot of other people, like Travis Oliphant for NumPy, have chosen Python. But really, the tech stack for Sage chosen long ago is Python plus Cython, which lets you write C extensions to Python efficiently. And I did a lot of early work with some of my students on Cython, including the important thing of making up the name, which is kind of silly, but it was a better name than the previous name of Cython before I forked it was Pyrex, just like the glass Tupperware type of stuff. And it wasn't really a good choice of name for many reasons. So anyways, these two programs are extremely different. One of them is an open source program that people use to do math research, to support math, symbolic computation, all that kind of stuff. The other makes it easy for people to work together on a wide range of computers And I'll give you a demo of CoCalc in a minute, but I'll give you a better sense of what this is. And just a little bit more detail. So with Sage, like I mentioned, we chose a tech stack decades ago, and it's worked pretty well and continued to work well. Python's got way better, Python's got way better, and just the nature of the software. Things have come and gone. People have tried to write, I guess the only other competing tech stack might be Julia, but that came around much later than when I started Sage. And people haven't really got that far with Julia for symbolic computation. So with CoCalc, on the other hand, when I started it seemed like the canonical thing to use was Python and Flask and Twisted, all that kind of ecosystem. But then within months, it was better to use JavaScript with Node.js, which had come out recently. CoffeeScript was a really nice language, much more like Python than JavaScript. And you should use jQuery, which was great, and it made it way easier to work with Internet Explorer versus Firefox versus whatever. So jQuery was really nice. But then, 2 years later, it was way better to use TypeScript and to use React. And also regarding just distributed web applications, there's this evolution from OpenStack and VMs to Docker Compose to Kubernetes. And basically the whole landscape and environment of building these scalable web applications with some compute behind them evolved enormously from 2012 until 2020 at least. So that was intense. Also, I made a number of choices along the way for various reasons. Like I used the Cassandra database for a while, but that turned out to be a really bad choice. I then rewrote everything to use RethinkDB, which was this really cool real-time database. But then the company that made it went out of business, just poof. I met with the founders, and like a few weeks later they were out of business. It was really weird. I could tell that something was going on, but that was pretty disturbing to see. So I don't know. Just there are a lot of like shifting issues like that. Another issue that was challenging early on is that when I did leave UW in order to get investor money and employees and so on, we didn't use the most open source license. We used the AGPL license for quite a while, and then we finally ended up switching to a source available license, which is even less open source. But this, maybe it was due to the nature of the software or the license, but it was much more difficult to get kind of free community contributions to CoCalc than with Sage. With Sage, it was fairly easy to get, literally hundreds of contributors across the board implementing really cool stuff. Whereas with CoCalc, it just was very hard to do that. I think it's partly just the architecture of the system and how it's not really such a broad system in the same way that like a large math software system is. Another thing that people very quickly just flatly demanded that there be an integrated course management system in CoCalc, which was something I didn't really expect. But they're like, I can't use this unless I can easily push out assignments to students, collect assignments, see exactly what students are doing in real time, all this stuff. And so we had to add that, and we've evolved that quite a bit over the years. But not only that, with CoCalc, we wanted people to use it at universities and all over. And like one of the early adopters was UCLA, which used CoCalc in some enormous classes with about 5,000 students a year. And they have a lot of compliance requirements that I just had not dealt with before, where they require that you have X million dollars of insurance and you have to pass all these security audits regularly, and they have accessibility checklists, and it's just like a whole can of worms that I had not encountered at all with Sage. That is expensive and tedious to address. And then finally, there's an endless amount of abuse that can happen if you make a public website and it allows for, in fact, the main feature of the website is arbitrary code execution. People go to CoCalc.com to use Sage, to use Python, to use all these programs, and hence they can run arbitrary code. And that's, basically the entire time that it's existed, there's been, and even way before it with the earlier products that created, there's always been regular issues of abuse that we've had to deal with. And that ranges from like somebody will get an account and then try to launch a denial of service account. I remember once we were hosted on Google Cloud, and Google Cloud said, we shut you off. And then we're like, why? And they're like, because you're launching a denial of service attack against the country Turkey. And I'm like, I didn't know that. So it's just some random user on our site doing this. When cryptocurrency was big and it was worth it to mine on CPUs, people would constantly try to do so. When we allowed people to pay, then we started having credit card testing issues, where people who had stole a large number of credit cards would then try to figure out if they work or not by making thousands and thousands of attempted purchases. People would publish, like, the second your site is able to send email notifications to other users, you've been invited to this project, people will make the email notification try to sell you something, and then try to send out as many invites as they can get your system to do. So it's just, and then there's just like flat out malicious users. I think one of the first malicious users I ever had was long ago at UW when I was hosting one of the clusters I mentioned. Somebody named, their like name was Byte Writer, and they would try to make account after account and then use up all disk space. It was just their thing. So there's just like so many little things to deal with like this. I've talked with people like pretty high up at AWS and other similar products to CoCalc, like cloud9.io, and they all have kind of like a similar history with abuse. It turns out that in modern times, like pretty much every single thing that's listed here, there's a pretty good solution one way or another. Like, you cut off a lot of problems by just not allowing outgoing network connections unless people pay you. Credit card testing, like Stripe has solved that with their products. DOS attacks are solved by Cloudflare. Just like modern technology deals with every single problem, but still you have to implement it all. So I'm just going to show you a quick demo so you can see what CoCalc actually is, because probably there's some substantial chunk of the audience listening to this right now that has absolutely no idea what I'm talking about in any real detail. And I apologize for that. So I'll just show you what CoCalc is. So I'm literally using CoCalc right now to show you this talk. And this is just a little bullet point of some features. I'm just going to fly through them really quickly in a quick demo where I'll use a terminal, I'll use a Jupyter notebook, I'll edit a file with LaTeX, show you how there's a built-in completely automatic revision control system for any file that you edit. And we also have file system snapshots. There's a course management system, a whiteboard, chat rooms, and lots of AI integration. So let me pop out of here and open a CoCalc project. So this is the website cocalc.com right here. And I'm signed in here. And then I have a project called Demo, which is not running, but I'll start it up. And notice I have lots of projects. So I think I have the second most number of projects of any CoCalc user. UCLA has more projects by far, but I have the second to most. I think at UCLA, there's a person with about 15,000 distinct projects. Each one of these projects is a file system, and when you start up running, there's a Docker container that is running associated to the project, and you can then use it. Notice we're in a web browser, and here I now have a terminal, and I can type top, and I can type ls. There's not going to be a lot of files there yet, and I can run programs. I'm going to run Sage, for example, and that will start up in a second. The disk is a little slow, which is something I'll get back to in a second. So I just did in case you're wondering what's going to happen soon, this next year is 2 times 1013. So if you learn nothing else in this talk, at least you know how to factor next year, so you'll be prepared for your fellow number theorists. So as you can see, it's a way to easily get a terminal. A key thing about CoCalc is that it's collaborative. So you should see 2 browser windows in a moment. And a little chat on the side here. And when you type in one of them, don't know why that isn't coming up immediately. Okay, there it is. So you can type chat with another person and they'll see a chat on the side and they can respond. You have like these different threads of conversation, and also one person can type in the terminal, like use Python, and then the other person will see what you're doing. So you can collaboratively use terminals and really anything else in CoCalc. So that's kind of one of the key features, that you have collaboration on an even level across everything. So I just made a terminal. A terminal is unlike in a lot of, well, pretty much every other piece of software where a terminal is kind of this ephemeral thing that you open. In CoCalc, the terminal has some like identity as a file. So you can name it like mydemo.term. So it's a term file, and if somebody else opens that .term file, they'll be using the exact same terminal as you. And there's like a log of all the file activity right here. Let me show you some other file types. So another useful one is a LaTeX document. So you can edit LaTeX files. And there's our very simple file. And as you can see, you have the document on one side, and then you can edit it on the other side. And you type on one side. Should remind you of Overleaf, which is a popular online LaTeX editor that's collaborative. This is similar to Overleaf, except I started it a little earlier, but they are kind of a similar idea. And again, of course, you have chat on the side, and you can chat with other people about the paper that you're working on. You can have lots of different source files. There's auto formatting. There's all kinds of features. You can select some text and make it bold. If you can't remember how to do that in LaTeX, you just click the button and it automatically does it for you. And one really cool feature about the LaTeX editor is you have high resolution time travel. So what that means is there's a little button, time travel, right here. When you click it, you can then look at all past versions of the document. Almost every keystroke is visible here. And this can be nice because if you had your document compiling just fine 5 minutes ago, but right now it's suddenly broken, you can figure out what went wrong. You can click on changes and drag a little slider and see exactly what changed. And you'll see, oh, I introduced this broken command right here. So it's a convenient feature. And this time travel interface where you can look at any document and go look at all the versions of it, which are automatically recorded and saved. Like, it doesn't truncate the history. It's really the full history. This exists for all the different type of documents you'd use in CoCalc. And then finally, if you have a bug somewhere, there's little buttons. You can ask it to tell you give you a hint about how to fix it or to fix the problem. And when you click that button, you get to choose an AI model optionally. And then, let's see, I'll use GPT-4.1 Mini for some reason. And when you click, it then opens up the chat on the side, and then AI tells you how to fix the problem, as you can see. So it's telling you what to do. And then it's fixed. Okay, continuing the quick little tour. So here's a Jupyter notebook. I'll just click Jupyter notebook. And so there are a number of different ways to use Jupyter notebooks in the CoCalc platform. One of them is through this interface that we wrote from scratch. It's a complete front-to-back implementation of Jupyter, from the Jupyter server on the back to the front-end client, designed for real-time collaboration. And it has some really nice features. For example, if you click text, you have a WYSIWYG editor where you can type math, and you can do things like take a screenshot and very easily just paste it, and then it appears right there in your editor. And you can easily drag and move things around and change the size. So it's a convenient experience for using Jupyter. It also kind of has an Emacs-like feel in that you can split a buffer and look at 2 different points in the document at once, which can be really nice for very large documents. There's another way to use Jupyter, which is you can click servers and then just click the Jupyter Lab button. And then this just runs Jupyter Lab. It pops it up in another browser tab in a second. And you can similarly run VS Code. These are running in your project, so it's using exactly the same files, but you get to interact with them via any of these other servers. So as you can see, Jupyter Lab started up running with one click, and then it's here, and then you can use everything that way as well. So in a sense, CoCalc, you could view it as just a nice collaborative platform for launching and working with these standard web applications. So here's the same notebook over here. And VS Code itself has, if you install the extension, also has a way of using Jupyter notebooks. Okay, let's see. I've shown you almost everything. I'll just give you a little bit more of a tour and then we'll move on. Let's see, I'll show you the whiteboard. So the whiteboard it's a whiteboard. You can scribble on it, make notes, just a whiteboard, but it does have one neat feature, which is you can make code cells and then run code. See how I was able to compute A plus B, not very exciting, but there's a Jupyter notebook behind the scenes right here in which all the code is actually run. But you can lay it out nicely, annotate things like consider this, and kind of have a nice whiteboard experience with lots of different pages and easily search for content in the whiteboard. So it's really just Jupyter, but a different way of accessing your notebook. Okay, so that is my quick overview of what CoCalc is in terms of all the editors and in terms of some of the kind of unique features of CoCalc. Like you have time travel even for Jupyter notebooks. So if you ever want to see what happened, you have that. And of course you have AI assistants all over the place. Like, you can ask, explain, have it generate a cell that does something, draw a spiral, that kind of thing. And you can also coordinate who is allowed to use the project here. So you can add collaborators. There's lots of configuration that you can do. Okay, so back to our talk, which is literally just slides are just a whiteboard with lots of pages that are the same size. Oh, one other thing, there's file system snapshots that get automatically created. So there's a lot of things to kind of keep you from losing your work. So here, you can see that there's lots of automatic ZFS, in this case, snapshots. So here's what the file system looked like 50 minutes ago, and here's what it looked like 6 minutes ago. And then here's what it looks like now. Okay, so now back to the rest of our talk. Okay, so now recent challenges to creating CoCalc. So you can see it exists. It is this thing that is there. But just kind of give you a sense, there's more challenges today in 2025. So bureaucracy, there's endless bureaucracy, as I've mentioned before, like just so many little things. For example, if you have a customer in Texas, then they have these surprising things that you have to agree to involving Israel. Like, who would even think that that would be a thing I would be thinking hard about? Is the company pledges to do something related to, I can't remember what the details are, but it's kind of funny. There are other things. So our market is almost entirely, currently it's mostly education in academia. So people use CoCalc a lot in teaching classes. It just makes things much, much smoother. We have had off and on people in like companies using CoCalc, but the main use case where it's really caught on is in education, and especially in the United States. And a few months ago, Google, which has infinite money, just decided to make Colab, which is another Jupyter notebook hosting platform, completely their professional version, which gives you a bunch of gives you a bunch of GPU compute and all kinds of things, completely free for absolutely any U.S. education, U.S. student or educator. So there's just no cost at all for the product that competes with CoCalc, whereas we have to pay quite a bit to host CoCalc, so we have to charge our users, and we don't have infinite money. So that is a challenge. There's also, of course, a lot of competitors. This product I'm describing is not only desirable to me, it's desirable to a lot of people, and hence there is a extremely fierce competitive landscape, which has its own, is a challenge. In terms of what matters for CoCalc now, there are really, I think, three big issues in 2025 and soon 2026, and CoCalc falls short in all of them. So the first is performance. So in CoCalc, due to how it's architected, there are a number of situations where the latency is just a little too slow, or maybe a lot too slow. To give you some examples, when you hit Shift Enter in a notebook, it takes nearly a second until you see output, even if it's very simple. And that is about 10 times longer than it should be. It should be about maybe 100 milliseconds. It should basically be your ping time to the server, and it's almost 1 second. And if you're taking a class, learning some basic Python and so on, that doesn't matter too much, but it actually does matter a lot if you're going to seriously use this all the time. And it's and then there's a number of other things. For example, if a project isn't running and you want to start it running, it takes, on average, maybe 6 seconds. Sometimes it takes 20 seconds. It depends. It should take about a half second, not a huge amount of time. There's a whole bunch of dumb overhead, and then it's starting a Docker container, which should take a fraction of a second. The disk that we use is a networked file. It's basically some sort of networked file system setup, and that introduces significant latency. If you want to build some software from source, if you're doing something that just involves tens of thousands of files, it really starts to get noticeably slow. Again, teaching a class using a Jupyter notebook, it's not a problem at all. Running through 10,000 images for machine learning training, or just building CoCalc itself as an example, or Sage from source, it gets very painful, because even if it's, say, 5 or 10 times slower, that could be hours versus 5 minutes. So it's really a non-starter for a number of professional use cases. And we do have on-prem hosted versions of this, but they're not sufficiently, you try out the online version thinking that's going to be the ultimate speed situation, not realizing it would be a lot faster to use it yourself. And then there's also reliability issues. So things are pretty good at the moment, but still overall everything is in one single zone on Google Cloud, and that's not great from a reliability point of view. If you're not close to the US East Coast zone, like you're in Europe, no matter what we do, the latency is going to be bad for you. And that's especially bad given that a lot of our users are in Europe. Another second point that is shortcoming for CoCalc today is AI agent integration. We have a lot of Copilot style integration where you click a button and it does one single interaction with a large language model. What we don't have a lot of, or really any in our release product beyond just using it in a terminal, is agent integration, like Claude Code, Codex CLI, Gemini CLI, etc. And honestly, that's clearly the future of how people are going to interact with data and code, is by using these coding agents. They work extremely well. Sometimes, if you know how to use them, they work reasonably well, and the amount that they're improving is impressive. So, it's just kind of like the difference between Python and C++ or something. When the type of application you're doing is suitable for Python, it's way better to use Python. Similarly, for a lot of applications, AI coding agents are a major step up over directly writing all of your own code. And so, and in particular in CoCalc, they are extremely useful because, basically you have this full sandboxed Linux terminal environment. You have your data and your files. You can just say, hey, add this thing to a notebook. Hey, create a bunch of notebooks that do this, or write some code that does this other thing with the data that I have here. And a really nice thing with CoCalc is you can have collaborators, and then you can all interactively see your interactions with AI. So it's not just you directly interacting with an AI agent, but you and other people can interact with the AI agent. So that's like a big missing thing, just really integration with the standard agents, which we need to develop. And then it's another big problem with CoCalc today is it's not easy to install. In fact, it's pretty much impossibly hard to install. We offer exactly one way you can install it on Kubernetes if you pay us a lot of money and we heavily support it. That's it. So that's not good at all. What it should be the case is that you download a 50 megabyte self-contained binary to Windows, Linux, or Mac, run it, and it takes about 1 second to start, and then you're running CoCalc. That's what installing CoCalc should be. Or you have a random server on a cluster somewhere that you have access to because your advisor said, here, you have an account on this university resource, for example. You should be able to just type a single line into the terminal and have CoCalc running there, and then have like a nice window that pops up on your laptop so you can very easily use those remote compute resources with very, very little friction. So we don't have any of these things, but I think all of them are by far the most important challenges for what CoCalc needs to have for people to really find it useful in 2026. The unfortunate kind of reality check is these performance issues involving latency and the installation issues are not easy things to address. You can't just, so for example, Colab, which does certainly have good performance, they don't have real-time collaboration, despite their name. The name is Colab because collaboration, and literally it has no real-time collaboration, which, or at least last time I checked, that was true. They had it a long time ago, but they got rid of it because it was somehow too difficult to do both real-time collaboration and the other things that they wanted to do. And so they just decided to nix the entire feature from Colab. And that allowed them to focus on really doing just one thing. CoCalc, on the other hand, really a big part of our goal is that we actually fully support real-time collaboration, especially with yourself. That's another, like time collaboration, meaning recording what you do over time and then be able to easily see exactly how things were automatically 10 minutes ago, 2 days ago, whatever you want. That's a really core feature of CoCalc. So these are recent challenges. And then I'm going to end my talk by just really asking a question. Is CoCalc even possible? Because the functionality I described is obviously possible. I've demoed it. You can see it running right there. It's used by lots of people. Hundreds of people are using it as we speak. And yet, what CoCalc is not really possible if it doesn't compete in terms of these criteria I just mentioned in terms of performance, really easy installability, which also includes installing as, say, a browser, an extension into VS Code, where you could combine, say, VS Code functionality with CoCalc's unique capabilities. And then, so the question is CoCalc possible? Can we make something that has latency that's comparable to running Jupyter Lab or Colab, and also has real-time collaboration and records what you do? And it also has latency that's close to you so that you can choose a server. If you're on the West Coast, you choose a server on the West Coast and you get latency as of under 50 milliseconds for typing in a terminal, for evaluating code in a Jupyter notebook. You want something that feels really good. And if you happen to have the right software installed on your own laptop, you can just use that directly via CoCalc. And of course, AI integration, which is probably the least challenging of the things that are listed there, because the really hard work is already being done by Anthropic and OpenAI and Google, and it's really just an integration problem. But it needs to happen. So fortunately, I got extremely disturbed by this problem and performance about 10 months ago, and I've been working on it extremely hard for the last almost a year. And this is not public yet, but we do have a lot of stuff in the pipeline that addresses all of these points. Like we have some pretty good agent integration. There's an implementation of really just basically a rewrite of the whole system that deals with a lot of the latency problems by just re-architecting everything. It's difficult to explain in detail, but there are a number of key pieces, and I can just say a little bit about those to finish off the talk. But One key thing in dealing with latency is make it really transparent and easy to have CoCalc servers all over the world in different data centers. And in the browser, you feel like you're just using all the same projects, but your browser actually connects directly to where the project is hosted. And so that cuts out a lot of intermediary proxying, and that helps a lot. But it's kind of tricky to get the right architecture to figure out how to deal with all the bookkeeping and security issues. They just get really complicated. So that's one key thing. Another is just really, really streamlining exactly what happens when you start up a project, exactly what happens when you evaluate code, etc. And that involves all over the place. Every aspect of that involves communication in a distributed system. And for that, you really need some sort of good pub-sub framework. An extremely good sort of design is in this thing called nats.io. It's a amazing open source pub-sub system. It's kind of like they define a really good, they give a really good definition for how a pub-sub system should work and what the rules should be. And then they have an implementation. I tried really hard to use it, and in my personal experience for everything I wanted to do, it actually was not very good. And so I ended up spending quite a bit of time and I re-implemented the whole idea and the definitions, but using Socket.io and Node.js, and came up with something that worked much, much better for us. And we've been using that in production for quite a while. And it's a foundation that we've been able to rebuild the whole architecture of our system on to be a lot more performant. Though, again, this is not live yet. So I remember once I was at a lunch with this mathematician who had, I guess, proved a theorem, and then another mathematician was asking them, where's the proof? And the person that proved the theorem just kind of pointed at their head. And it's like, you're completely convinced you can make something, you can build something, you can describe a machine that works. But until you actually write it all down and double check it, and other people are convinced by using it, it isn't really real. And certainly, CoCalc is that in a sense. So let me just end by saying that the thing I want is functionally like what the CoCalc site provides, a collaborative, friendly way with automatic history tracking of your editing, and really easy collaboration with other people. But at the same time, it has performance and low latency that's good enough that any of you listening to this would actually use it, so that I would actually use it without feeling frustrated. And these two things are a direct conflict with each other. There's a tension. You can do one easily without doing the other, or you can do the other easily, but then you give up on all the functionality. And so doing both at once is the kind of tricky balance. So with that, I am done with my talk. And are there any questions?
Well, thank you for that talk. It was really interesting. So any participants out there, you can raise your hand or type something into the chat if you have any questions. I actually kind of an open-ended question, kind of related to these kind of new features and rebuilding the system, which is how do you think about kind of when you've already released, like people are already using CoCalc, and you're kind of rebuilding it. So when do you, like when do you, how do you kind of decide when to release something, when it's kind of ready to go, and then you may have to, people are using it, and you have to, rebuild it or re-release it, or there's this kind of trade-off. You're kind of building something that's mining somehow. Yeah,
that is a painful, I have PTSD from having released things sometimes too early and switched. We've gone through probably 5 different ways of storing projects, like the file system type of stuff over the years. And some of those transitions were extremely difficult and premature, and maybe resulted in some data loss or just the site being down. This one is, this rewrite that I've done in the last year is extremely major. Like, it's probably about 1,500 commits, and that haven't been merged into master yet. It's like a really pretty much every piece of the software is rewritten except for the front end applications themselves. But like the whole underlying foundation is rewritten. And unlike I think every past major architectural change that I've made in the system with other, but just to be clear, I'm not the only person that works on CoCalc. There have been many people over the years, and the team right now is 4 of us. But it's been bigger or smaller over the years. I didn't say anything about that, but I just want to be clear that I'm not the only person working on this. But yeah, so what I'm going to do with this is make a second website and let people optionally migrate their work over to the new site. And it'll probably be called, I don't know what it'll be called, maybe CoCalc.ai or CoCalc. Something else, or maybe next.cocalc.com, or something different, something slightly different. It's a completely different site, and you can optionally migrate your files. And that way we can have kind of like a gentle beta testing period, and then people can make sure that it works really well for what they're doing. And we can also brand new people. There's a lot, like every single day we have like between 500 and 1,000 new accounts get created, often just random people finding CoCalc via Google, and almost none of them stick around. Like we have a horrendous, basically the people that stick around are the students that are forced to use it in classes, which feels terrible. But the random people that just find it, use it a bit, and then they leave. And I think it's just because they're like, this is not fast enough for me, or it's just not a smooth enough experience. Because they like our website explains what it does. They find our website because of what we say we do. It does the things we say, but it doesn't do them well enough. And so bringing that back to what I just said, we'll direct a lot of those people to the new site. The instructors can still keep their courses stable on the old site. We'll direct a lot of the SEO kind of people that are coming in via searches to the new site. And then when we're sure that the retention is better, then we can start transitioning our main user base over. So that's the plan for this massively, different architectural change.
I see. Okay, yeah, that's very. So you said there are 4 people, including you.
Yes, including me. Yeah.
And that the other 3 are full time.
Yeah. There's been 4 of us full time for quite a while, and so we had a 5th person maybe 3 years ago, and then there's been people that have come and gone over the years, but there are a core of 4 of us right now working on CoCalc full time.
I see. So is the company like profitable? Like, or is there a net?
Almost, but not quite. We would be profitable with 3 people. Let's just say.
I see.
Yeah,
okay.
But not with 4. So, yeah.
Okay. Well, yeah, it's very interesting. It doesn't look like there are any audience questions if I'm reading the Zoom controls correctly. So I'm going to go ahead and post the link in the chat just to make sure everyone who wants it has it. So this is the link to the kind of after talk smaller discussion.
Okay.
So that should be available to everybody. And so I think we can. I don't know if Nathaniel can hear me, or someone should stop the recording at some point. I think we can end this session, and then whoever wants to can go over to the second